One, two.
Hey, this is a demonstration of the Neato Botvac using the SV Ross into the Ross package. I have a Neato Botvac right over here, and inside the dirt bin there's a Raspberry Pi, and again it's using the GitHub from Intro to Ross. It's using the SV Ross GitHub Intro to Ross, and that's the Raspberry Pi. First thing I'm going to do is create a map. So with Ross, I load in the G mapping routine, the grid mapping routine that's loading in now. And you can see that there's the Botvac. And it's already started creating its map. I'm going to load in the teleop module so I can control the robot with the keyboard. This is mapping. You drive it around, you create the map. Then I'm going to save the map and then load in the navigation stack, and then I'll be able to navigate autonomously. So here's Ross's G mapping for the grid mapping, and again I've got the teleop loaded in, so now I can use the keyboard to control the robot. I'm driving forward. And I'm going to map out, this is the computer room, and I'm navigating into the living room. Here you can see the map that I've created so far. Let me make it a little smaller. Okay, and I'll continue mapping. So here you can see the map that I've created so far. Now I'm going to drive it back into the computer room. Little driver error there. I don't think it messed up the map though. So typically when you create a map, then you save the map. So here's my map. Let me straighten it up here. Typically when you create the map, you drive it around. You could use a keyboard, you could use a joystick too. But there you see the computer room, the living room, and you used the G mapping, grid mapping routine in Ross to do the mapping. Now I'm going to save the map. You have to save it in a very specific subdirectory. Okay, so now I've saved the map, and I am going to kill the G mapping routine, the grid mapping routine. There you can see it's gone, and I'm going to load in the navigation stack. NavGUI. The navigation stack includes the map server, which loads in the map that we just created. Also includes MoveBase, which is your path planner, and something called AMCL, Adaptive Monte Carlo Localization, which is your localization routine. So I'm going to paste this this navigation stack in. Okay, so now it's loaded in the map that we just created. And you'll see the global cost map is the blue all around there. The wall, the blue coming out from the wall is the inflation barrier that tells the robot how far or how close it can get to the obstacle. That's adjustable in the parameters. So now I'm just going to click on 2D nav goal, point, press, and drag, and the robot will autonomously navigate to that spot on the map. So here you can see that the robot is positioning itself on that point in the map, and it can adjust to the path planning, can adjust to dynamic obstacles that might introduce themselves, or if furniture gets moved or something like that, it can adapt and go around it. So now you can see where the robot is in the map. I'm going to click in here in the living room. I go to 2D nav goal and press and drag, and whichever direction I orient it, that's which direction the robot will be facing. That's its pose. And I mouse up, and you probably can't see it through the computer, but there's a green line. That's the path planning line, the move base, and you can see the robot is autonomously navigating to the goal that I set. See, he's going through the corridor there. And this is autonomous. I'm not controlling the robot. You can see where it's getting a plan, getting a plan, getting a plan. And then when he finally gets to the location, it says goal reached. Okay, so now here, okay, you can see where he is on the map and the screen, and I'm just going to click 2D nav goal, the other side of the room and facing the opposite direction, mouse up, and you can see the robot navigating to the other side of the room and facing the direction that I pointed. Okay, and so now he's arrived where I selected. Now, one last navigation. I'm going to click 2D nav goal, and I'm pointing at where we started. And point, press, and drag, mouse up, and you'll see the robot navigate there. He's actually looking at going a different way because we were standing in the original path. See if he gets lost in there, because that's unknown space. Okay. Looks like he's trying to come back. I'm actually helping him out here. Okay. He went into an area there that we didn't have to map, that we didn't have mapped. So I've driven him back into the space that we do have mapped. And he should be able to figure out where he is from here. There he goes. He's gotten relocalized. Well, that was quite an adventure. Okay, so now he's going back to where we originally started. And you can look at the map here and see him going back to the place that we started. Actually, looks like there's an obstacle there. I'm going to move him out a little bit. There he goes. And he's reached the goal. So that is mapping and navigating with the SV ROS, Intro to ROS package. That's the Neato Botvac with Raspberry Pi. Thank you very much.